Welcome back to Topic 35 for Algebra 1, Recursive Formulas. In Part 3, we're going to explore translating between recursive formulas and explicit formulas. In our first example, we are asked to write an explicit formula if we're given a recursive formula. And remember that there are two different kinds of sequences that we've dealt with: arithmetic, which is linear, and geometric, which is exponential. So in this first problem, on the left-hand side, we have a sub 1 equals 7, so the first term is 7, and we also have a sub n equals a sub n minus 1 plus 4. So here we have a recursive formula, and also always keep in mind that recursive formulas work for when n is greater than or equal to 2. So it works for finding the second term and up. Since we want to write this in an explicit formula, let's first recall what the explicit formula for an arithmetic sequence is. So an explicit formula for an arithmetic sequence can be written as a sub n, so the term that we want, equals the first term, or a sub 1, plus the quantity n minus 1 times d, times the common difference. If we look at the given information in our recursive formula that was provided, we can use that information to plug in. Since we already know that a sub 1 equals 7, we can plug that in as well. So our new formula will be a sub n equals 7 plus n minus 1 times the common difference. Now, what is the common difference? The common difference is this value right here, this 4. So I'm going to multiply this n minus 1 times 4. Now, all I need to do is simplify. So I can distribute this 4 into the quantity n minus 1, and I'm left with a sub n equals 7 plus 4n minus 4. Now I can combine like terms. I have my 7 and my negative 4, which gives me a sub n equals 4n plus 3. And that's it for an arithmetic sequence. Now if we have a geometric sequence, let's say my first term is 8. So a sub 1 equals 8. Now for the second part of the recursive formula, I have a sub n equals 3 halves times a sub n minus 1. So 3 halves times the previous term gives you the term that you want. Let's recall what the explicit formula looks like for a geometric sequence. For a geometric sequence, we write this as a sub n, the term that we want, equals our first term, a sub 1, times our common ratio to the n minus 1. Now this example is also super simple because all we have to do is plug it in. We know what a sub 1 is because it's given right up here. So a sub 1 is 8. Now my common ratio is my 3 halves right here. Oftentimes we see it in recursive formulas. We say a sub n minus 1 times our common ratio. But normally with standard, when writing it, numbers, we commonly see it with the ratio listed first, numerically that is. So this common ratio is 3 halves in this example. Then we're going to raise it to the n minus 1, and we're done. Okay, now let's try to flip it around. What if we have an explicit formula and we're asked to write a recursive formula? So again, we're going to do one example for arithmetic and one example for geometric. For arithmetic, we have this formula of a sub n equals 1 plus 1 half times n. Now let's recall for a recursive formula for arithmetic, we have 3 parts that we need to mention. We need to mention the first term. We have our pattern, a sub n equals a sub n minus 1 plus our common difference. And then this applies for when n is greater than or equal to 2. Now with this explicit formula, we don't know the first term right off the bat, but we can plug it in. So we're going to find the first term. Because it's explicit, we don't need to worry about having the second term and up. We can just plug in 1 for n. So I'm going to get a sub 1 equals 1 plus 1/2 times 1. Again, all I'm using is this original given explicit equation. Now I can simplify. A sub 1 equals 1 plus 1/2. So a sub 1 is going to be 3/2. So when writing my recursive formula, I know that the first term is 3/2. When I'm identifying my pattern, I'm going to have a sub n equals a sub n minus 1 plus my common difference. Now my common difference is this 1/2 right here. So all I'm going to need to do is just add 1/2. And this applies for when n is greater than or equal to 2. Moving on to geometric. Here we have the example a sub n equals 9 times 8 to the n minus 1. So the recursive formula for a geometric sequence is we need to find the first term. We need to plug it into our pattern, a sub n equals a sub n minus 1 times r, and this applies for the second term and up. Now here we don't need to actually find the first term because it's given in this explicit formula. The first term is right here. Now the common ratio is also given. So all we need to do is just plug in. So a sub 1 is 9. A sub n equals a sub n minus 1 times 8. Or sometimes we might see that as, I'm going to write it above, a sub n equals 8 times a sub n minus 1. Either will work, just keep in mind that you may see it both ways. And this applies for when n is greater than or equal to 2. And that is it. That is translating between recursive formulas and explicit formulas for part 3 of topic 35, recursive formulas for Algebra 1. Thank you for watching.